getting started on a WPC MPU from a Terminator 2, one of my favorite games I used to own. And you can see there's some alkaline corrosion on those 10K pull-up resistors below the battery holder. I'm going to need to remove at least J206 because you can see some corrosion. The green part there is dripped down onto the connector, and it would be advisable for the client to repin the female housing. So let's see what's underneath that connector. Here I've removed the 6264 RAM, installed a socket, and I will install a NV RAM in that location. I always cut W15 through 18. That sets the MPU to USA 2, which is kind of universal. And I have removed some 10K resistors and the ULN 2803 that were in this corrosion area. So I'll dress this up with some sandpaper, get down to bare copper, and then reinstall these parts. A lot of times I'll remove the ULN 2803 at U20 and install a socket just for future maintainability, as was done in the WPC, or beginning with the WPC-S MPUs. But I need to take this J206 off. So let me show you how I do that. Some of you have seen this before. I've got this JBC spade blade, I call it. It makes taking these things off a snap. Now sometimes you have to add solder, but in this case that was not necessary. So let's see what was underneath there. Excellent, no corrosion. So I won't put this connector back on. I'll replace that with a new connector. Now we have an opportunity to show you how I remove components kind of quickly. So I'm going to remove this voltage watchdog, and the first thing you need to do, using this technique anyway, is add solder to the part. And you can add quite a bit of solder to the part, and then you just end up dancing across those, heating all the holes at the same time, and the part comes out. I think this is a pretty safe and certainly effective method of removing parts. There's no torn through holes that can happen when a lot of folks will drive their Hakko desoldering iron or whatever down onto the pad, and these pads I found to rip up from the PCB pretty easily. But all I need to do is clean out those holes, them are holes, I'm in Missouri, and install a lower voltage reset generator. I use an old Molex 12-pin housing as a block to block sand the corrosion. One of my favorite tools to use is homemade leg straightener. Lets these larger chips go in without any trouble at all. I spoke too soon about no corrosion underneath the connector at J206. You can see all of these are good, but this one has got a problem, and it's always where the trace meets the pad, right in this location. Corrosion and on top also seems to build up and sever that trace. Now this is a pretty easy fix. I'll use some wire jumper and thread it through the hole and then down this trace just to put it on the front side of the board. It'd be just as easy to put a jumper on the back side of the board from this pin to this pin. J120 was a bit of a mess, so I got to use my copper tape to repair those traces, and also some rivets to repair the through holes. And a shout out to Jerry Claus. He turned me on to using these rivets for through hole repair, and also the funnels that I mentioned in a previous video. Jerry is a great tech, and he's one of only 3 other guys that I would trust with my boards personally. And here we are with a power driver board from a WPC Terminator 2. MPU came along with it. On the MPU, I have installed NVRAM. I've installed a new filter capacitor at C31. J210's been changed. This is the one that had some alkaline corrosion, and I hope I rolled in some pictures there. So I have abated that. I had to replace a few of these 10K pull-up resistors. I socketed the ULN 2803 and replaced the two center switch column connectors and repaired a trace under there. On the driver board, C11 was horribly bulged, exploded I would say, and so I have replaced C5 and C11. To protect C11 in the future, I've installed this 1N5401 diode, blocking diode. This prevents you from connecting the connector at say J106 or maybe it's 107 to down here where there is a pin for pin match, and that's how C11 gets exploded. I've replaced the headers all the way around for GI and power, and let's turn some GI on. Speaking of that, looks like I haven't got everything plugged in yet. And is it safe to do this, to plug things in while power is on? Generally, for most newbies, I'd say no, but for me, I've done this a million times, or I know what's going on, so I feel safe doing that. Now, solenoid 11 is lit. Let's go figure out what that is. Factory settings restored, because this is the first time that I booted it. So one good thing is that it's coming up time and date not set, which I would expect. And the gun cannot find home. Gun can not find home. Well, let's get into tests. We'll test the switches first, going across the diagonal of the switch matrix. Looks like I've gotten off by one as I was walking across there. Let me try that again. What on earth? That switch matrix display is not a square. Oh, let me figure out what's going on there. Take two, but I'll remember to press the record button this time. But I have a Terminator 2 MPU that had alkaline corrosion on it. I have replaced C31, the 5-volt filter cap, J210, this power header input. Here's the alkaline corrosion abatement. 8 10K pull-up resistors were replaced there, necessarily so, as they were corroded. And the ceramic cap, which I refer to as the ceramic cap to nowhere, because early versions of this board, one end of this cap wasn't tied to anything, but I replaced it because it was corroded. And I removed and socketed the ULN 2803. That's just good future maintenance work there. I've abated the corrosion underneath the column headers, both column headers. This one was disconnected from the lower one on this rightmost trace, so I've tack soldered a piece of jumper wire in there, and it's a good solid connection now. Got NVRAM installed, the power driver board that came with it. Nothing unusual except two things. One is that C11 was exploded. This mostly happens because this connector gets connected down here. This has got 70 volts solenoid voltage, and that cap just can't handle that. Also replaced a tip 102 at Q22, which was open and not driving the circuit properly. The voltages on the board, 4.93, that is fine for the 5-volt circuit. 12-volt regulated, 14.7 unregulated. 20 volts and 70 volts are the flash lamp and the coil power respectively. Let's see, let's test the switches, and you can see that that is not an 8x8 matrix. T2 being an early game, I guess they had just the software developer had not standardized on an 8x8 matrix when the rightmost column was not used. So I've gone across the diagonal, and here's the lower right switch. That threw me for a loop when I saw that. Solenoid test. Make it run. And when it gets to this solenoid, you'll see that that's on for an extended period of time. That is the gun motor drive solenoid. So the software designers pulse the solenoids long enough for the operators to be able to ensure that they're working. GI test, and I should have showed you this, but there's another thing I'll show you in a minute. The green string is the CPU on the playfield of Terminator 2, and that string flashes when I first saw that, and this always throws me for a loop. It was flashing, and I was wondering why. Q22 is the circuit that was inoperative for the flasher. Lamps are working just fine, and that is it for this CPU. And I'll show you what I mean by this GI lamp blinking. So she's all back to normal. Replace this 5-volt cap, or this cap in the 5-volt circuit, and of course C2 over here, which leaks. Thanks so much for sending it.